today's video, I'm going to talk about earthquake P wave and S wave travel times. So we're going to be using page 11 of the Earth Science Reference Table. First thing to look at is the chart itself on page 11, and we can see as epicenter distance along the x-axis along the bottom. Notice that this is in scientific notation, so times 10 to the third means that you're going to add 3 zeros or multiply each number you see here by 1,000. So this first line in bolded is 1,000 kilometers away from the epicenter, 2,000 kilometers away, 3,000 kilometers away, so on and so forth. The other important piece of information is to know that each vertical line is 200 kilometers apart. So, knowing that each vertical line is 200 kilometers apart, we can round to the nearest 100 kilometers fairly easily. If we look at the y-axis, that's going to be travel time of either the P wave or the S wave in minutes. The interval here is going to be 20 seconds for each horizontal line. So we can round to the nearest 10 seconds. So we're going to take a closer look at this. We're going to zoom in to the lower left-hand corner of this chart. And so we've zoomed in, and we want to know what the epicenter distance and travel time is represented by each colored dot. So the blue dot, purple, and orange here. But first, we're going to just remember our intervals. So each vertical line is 200 kilometers. So what does that look like? This is going to be 200 kilometers, 400, 600, 800, 1,000, 1,200, 1,400, 1,600. So what does that look like in practice? Well, we can go ahead and label these. Now we look at the y-axis. So our y-axis goes up by 20-second increments. So here's 20 seconds, 40 seconds, 1 minute. 1 minute and 20 seconds, 1 minute and 40 seconds, 2 minutes, 2 minutes and 20 seconds, 2 minutes and 40 seconds. So once we have those values labeled, this becomes very easy to determine what is the value of each dot. So we want epicenter distance first. So the blue dot is at 800 kilometers at a time of 1 minute and 20 seconds. The purple dot is halfway between 1,000 and 1,200. So that's a distance of 1,100 kilometers at a time of 2 minutes and 40 seconds. And the yellow dot is at 1,400 kilometers. Then it's halfway between 1 minute and 40 and 2 minutes. So we'll call that 1 minute and 50 seconds. So our first round of practice here, actually reading the chart. So how long would it take a P wave to travel 2,000 kilometers? Remember, it's a good idea to put a box around what we're looking for. In this case, that's a time, how long, and underline the information that we know. So the information that's provided in the question. We know we're looking at a P wave, and we know that P wave is traveling 2,000 kilometers. Okay, so how do we start here? Well, we take a look at our chart, and we know a distance that we're traveling, and we also know that we're going to be looking at a P wave. So at a distance of 2,000 kilometers, we would draw a line here or kind of hover over the page with a pen or pencil or your finger. And we go from 2,000 kilometers up until we intersect the wave in question, the P wave, and we want a time, so we need to go over to the y-axis, that's our time axis, and we can see this is at a value of 4 minutes. Another example here, how long would it take an S wave to travel 2,000 kilometers? So again, we're looking for a time. We know we're dealing with an S wave this time, same distance of 2,000 kilometers. So we go over to the chart, start at 2,000, go up until we intersect the S wave curve, and then we go over on our time axis. This is at 7 minutes and 20 seconds. Bit of a different question. This time we're looking for how far. So we're looking for a distance. We're given that we're dealing with an S wave that's traveling for 15 minutes. So you always start with what you know. We know the time is 15 minutes. We're looking for an S wave. And then we go down for a distance. That distance is 5,000 kilometers. Our fourth example, how far can a P wave travel in 10 minutes? So again, we're looking for a distance. So we're going to end up on the x-axis. Here we're dealing with a P wave and a travel time of 10 minutes. So we start at 10 minutes, go over till we intersect the P wave, and then we're going to go down to the x-axis. And we're at a distance of 6,600 kilometers. bit more complicated example is if you're given s minus p time. So what does that mean? Well, the s wave and the p wave curves are separated. And you notice the farther the waves travel, the bigger the separation becomes. The S wave is slower than the P waves as they travel through the Earth's interior. So what is this question asking for? It's asking for the epicentral distance. So we're going to end up again on our x-axis here. And what do we know? We know the time difference between the S wave arrival and the P wave arrival is 10 minutes. So the space between them needs to equal 10 minutes worth of time. So how do we answer this kind of question? Well, you're going to use the travel time axis to mark off 10 minutes on a piece of paper. And this can be anything. It could be a scrap paper, it could be the edge of a worksheet, on a Regents exam, the edge of your test booklet, whatever you have available to you. So we're going to mark off 10 minutes worth of time on your paper, and then you're going to move your paper and slide it until this amount of time lines up in between your P wave travel time curve and your S wave travel time curve. We move the paper over until this 10 minutes worth of time fits perfectly between the waves. Once we find that point, we go down to the x-axis to figure out our epicentral distance. And here we have 8,800 kilometers. Here's practice problem number 1. As always, feel free to pause the video and give this a shot for yourself. So we're looking for how long did the P wave take to get to the station. So we're looking for a travel time of a P wave. And what do we know? We know the epicenter distance is 7,600 kilometers. So we're going to start with what we know, and we know that we're at a distance of 7,600 kilometers. We're looking for a P wave travel time, so we go up from 7,600 till we intersect the P wave, and because we want a time, we're going to go over to the left, travel time of 11 minutes. Practice problem number 2. Again, feel free to pause the video and give this a shot for yourself. Here we're looking for a distance, so how far away was the epicenter? And we know that we have a P wave that took 5 minutes and 20 seconds to arrive. So here we're going to start at a time of 5 minutes and 20 seconds, go over until we intersect the P wave curve, and then we're going to go down to the x-axis to determine the epicenter distance of 2,800 kilometers. Practice problem number 3, our last of the video. We're looking for an epicenter distance, and we know that the S minus P time, the difference between our S wave travel time curve and our P wave travel time curve, is 6 minutes. So we start with the y-axis, we mark off 6 minutes on a piece of scrap paper, and we're going to move our scrap paper along the chart until this amount of time fits perfectly between our P wave and our S wave curve. So that position is right here. And then we're going to look straight down to the x-axis in order to figure out the epicenter distance of 4,400 kilometers. I hope you enjoyed the video. If you have any comments or suggestions, please leave them below.